My name is Tom Silhavy. I did my undergraduate work in pharmacy school at Ferris State University in Michigan. I did my graduate work at Harvard Medical School. I did postdoc at Harvard Medical School. I'm currently a professor at Princeton University.
Yeah, and then how did you get into research in the first place? Like, where did you start? Undergrad, high school, maybe?
Like I said, I went to pharmacy school. And to be honest with you, pharmacy school was really frustrating for me. Pharmacists are overtrained for what they're allowed to do. I had a professor in pharmacy school who was a medicinal chemist. I started off doing research with him and with some organic chemists. I thought that I thought I was really interested in chemistry, so I thought I'd go to graduate school in chemistry, but my research advisor convinced me to do biochemistry instead because he thought the future was brighter there. So I did that. My PhD is in biochemistry, but my postdoc is in genetics, and
Oh,
genetics is what I do now.
yeah. And then that actually leads into my next question. Could you explain a little bit about your research in terms that a high schooler would understand?
Okay, you probably know that there are two major classes of bacteria in the world. They're gram-positives and gram-negatives. Have you heard of that? That's named after a stain that was developed by Christian Graham in the 1880s. So what it does is it says that the cell envelope of those two classes of bacteria is quite different. That's why one stains and one doesn't, okay?
Yeah.
So gram-positive bacteria have one membrane, the cytoplasmic membrane, and that's the peptidoglycan cell wall. Gram-negative bacteria have two membranes. They have a cytoplasmic membrane, a thin peptidoglycan cell wall, and an outer membrane. And the outer membrane does two things. It contributes mechanical strength to the cell because the peptidoglycan is probably only one molecule thick. It's a very effective permeability barrier. So gram-negative bacteria are innately more resistant to most antibiotics than gram-positive bacteria because the antibiotics can't get across the outer membrane. So that outer membrane is built on the other side of the cell wall in an environment that doesn't have any ATP. So what my lab is trying to do is to understand how the bacteria builds that membrane. If we could figure that out, then we could maybe find a way to break the permeability barrier and make them more sensitive to all antibiotics.
And then you mentioned that your work is in genetics. So how does that play into what you're trying to do?
Mutants.
What's the biggest challenge you face in research or in your career?
Probably the biggest challenge is attracting good people, to find good people to work in the lab.
Yeah, and when you say that, do you mean colleagues or like undergrads?
Mostly graduate students and postdocs.
And then why is that?
You have to convince potential graduate students and postdocs that they can do well here. And if they do well here, they can move on to the next step in their career.
And then similar to that, what type of traits are you looking for in a good researcher? Like what do you think defines like someone you would want to work with?
Motivation.
Anything else?
I think that's the most, well, I want them to be intelligent.
Yeah, obviously.
But motivation, doing research is hard.
Yeah.
And if you want to succeed, you really have to love it if you want to succeed.
What's your favorite part of research?
My favorite part of research, sitting down with graduate students and postdocs and trying to figure out what the results mean.
Oh, okay. Not setting up the actual experiments.
Well, that's part of it. The way it works is you do an experiment, you get some results, you try to make sense out of the results, and then you might develop a hypothesis or a model for what's going on, okay? So once you have a hypothesis or a model, then you can think of an experiment that would test the model. So in particular, you want to think of an experiment that would disprove your model.
Oh, okay.
You should always be trying to disprove what you think is going on.
You mentioned earlier that you went from chemistry to biochemistry. Beyond your professor recommending you to do that, was there any other motivating factors? And then are you grateful for that change, or do you kind of wish you stayed with chemistry?
No, I'm very grateful. In particular with biochemistry, my advisor thought that membranes would become a big field, and that is certainly true. I do genetics, but I'm still working on membranes.
And then he said that the field is expanding, and I assume that was quite a few years ago. And coming into the 21st century, a lot of technology has emerged when it comes to genetics and other fields. Where do you see our future going in this field? What do you think is the next big thing?
The next big thing is probably cryo-electron tomography.
Could you explain a little bit about what that is?
It's a way of doing structures of cells. So you can actually take a thin section from a cell and examine the proteins in that cell at nanometer resolution. So you're
And
going
then
to be able to see the structure of proteins within cells.
that's incredible.
It is incredible. They're not there yet, but they're going to get there.
How did you find your passion for research and for your field in particular? And then how do you suggest a high schooler find that?
Be honest with you, Anne, when I was in high school, I had no idea what research was or even what a PhD was. I never met a PhD until I went to college.
Oh, really?
Oh, yeah. So I didn't even realize that graduate school was an option when I was in high school. I liked science, but I went into pharmacy because I thought that's science.
Yeah.
And I can get a good job. I mean, the other thing that's really interesting is that going to graduate school is not like going to medical school. If you go to medical school, you have to pay a lot.
Okay. Yeah.
If you go to graduate school, they pay you.
Oh, okay.
So most graduate students are given a stipend. You can graduate from graduate school without being in debt.
Hmm.
You probably won't be wealthy, but you won't be in debt.
Yeah.
So when I decided to go to graduate school, I thought, why not give it a try? That's how it went.
How do you suggest high schoolers get into research? What do you think is the first step that high schoolers should take?
Well, you can write to professors and see about getting in to do research, but it's a lot harder for high schoolers than it is for college students.
Yeah, I've definitely noticed that. And then even if they're not in a wet lab, like what do you think they can do on their own time to make them a better applicant?
Well, I think you want to take all the courses that you could take.
Yeah, most definitely.
That's probably the best thing you can do. I mean, when you go to college, you almost have to make a decision. I want to do science or I want to do something else on day one. You don't have to say what science. The prerequisites are such that it's basically 2 years of prerequisites for any science.
Trying to get those out of the way.
Do well in your science classes. If you know somebody that works at a university, or if you know somebody that went to graduate school, you can try and learn from them. You can try and talk to them. Hometown, though, there wasn't. I came from a really small town, right? Like I say, I never even met a PhD until I was in college.
But I mean, it worked out. And then what other tips would you give a high schooler outside of the advice you've already given?
Like I say, it's got to be something that you really want to do. Research is a very competitive career. I'm not the only person in the world trying to understand the outer membrane. There's people all over the world trying to do this. So you have to really love what you do. The good thing about research, if you're doing research in academia, then one of the things you do is travel around the world and talk about what you do. So, I mean, there isn't a big university in this country that I haven't been to. And there are people, especially in Europe, to a lesser extent in the East, Japan, China, and Australia, that I don't know well enough to have dinner with.
Oh, wow.
I
Yeah,
mean, it's wonderful. If you do research in a company or for a corporation,
it's
you
different.
usually are not allowed to talk about it.
Oh, yeah.
Their company secret. So there's lots of things you can do in the corporate world. You might be able to make a drug that actually saves lives, for example. But usually you can't talk about it as much as people who work in academia.
But yeah, that's all the questions I had for today. Thank you so much for your time.